Okay. Hello, my name is Anukaran Jain and this is my tutoring demo. I have taught friends in the past and little kids that lived around me and needed help with their homework, and they all ended up understanding, so I'm pretty sure I'm a good teacher. Anyways, today I'm going to talk about playing with graphs, which is very important for estimating answers, and we're gonna get right into it. So for a function f of x, let's just say f of x is sine x for our, so we get enough variety to play around and include all the scenarios. So sine x looks something like this. Hold up. Something that, okay. Sine x looks something like this. Uh-huh. This is 0, 0. This is pi. This is 2 pi. So if you multiply a function with some number, say n f of x, it becomes n sine x. So n could be any number, 6, 7, 8, 9, any number. Then it just adds a multiplier to the height of it, height of the function, so the function just becomes taller and deeper. Essentially, the amplitude increases. This is what it would look like, our sine function. So it would still meet this point at pi, still meet this point at 2 pi. But here, it was maxing out at pi by 2 at y is equal to 1. But here, it would be y is equal to n, the maximum of this function. Same with dividing it, it just flattens the graph. So if you write fx by n, it's essentially fx times 1 by n, and 1 by n is just a small number, so it's like a small multiplier, so it will just flatten the graph. And yeah, and so it will still meet this point at pi by 2, I mean pi, still peak at pi by 2, and this point will be 1 by n, or f max times 1 by n, whatever f max is. Now if you write a function f of x plus n, what this does is shift your function to the left. So when you, let's deal with f of x plus n, plus minus n. So for any function, this is essentially y is equal to something of x plus some number. So it's going to shift the number, shift the function up and down. So let's just say n is 1 here, and f of x remains sine. So let's go with sine x plus 1. So what happens is this line was supposed to be, this bottom line was supposed to be y is equal to -1. But since we have shifted it one step upwards, all the crests are going to line up with the origin now. And this would be f max plus n, which would be 2. Let's deal with f of x plus minus n. So this shifts our graph to the left or right. So when it's outside the function, when it's outside of f of x, it shifts it up and down. But when it's inside the function, f of x plus minus n, it shifts it to the left, shifts it to the right. Because essentially it is manipulating where the new x is. So this can be just written down as f of x2, let's say. And x2 is just the new coordinate for the same function, because at least for sine x, the change in x is not changing the peak at which it changes. So instead of peaking at x is equal to pi by 2, instead of peaking at x is equal to pi by 2, this function would peak at x plus n is equal to pi by 2. So for n being a positive number, x has to be reduced. So it would peak before x is equal to pi by 2. So let's just say n is, for sake of simplicity, n is pi. So our function is sine x plus pi. So this would be pi by 2 when x is negative pi by 2. So actually our graph will be shifted pi units to the left.